All right, so the previous lesson we did dilations on a coordinate plane, which was a little easier because we could just use the idea of slope and count on how to get from one point to the other. Today we're looking at dilations with a compass and a straight edge. And as you can see, we don't have any grid behind the drawing, so it's going to be a little different today. So if we look down at the directions, it says lightly shade triangle ABC, and it really does mean lightly shade. We don't need to darken it all in. Just give it a nice light shade. As you can see, point P is inside the triangle, so we obviously still need to be able to see point P after we shade. So just a nice light shading there of the triangle that we are going to do. Then the next direction says draw a ray from P through A. Now again, we want to make sure we draw it through, so we're going to take our straight edge, line it up at P, going out through A, making sure we're drawing this ray long enough. Okay, so you should have a ray that's drawn from point P through the vertex A. And then we're going to use our compass. We're going to use our compass to measure because it says use your compass to mark on the ray A prime twice as far as A from P. Well, I need to know how far is A from P to start with. So I'm going to place my compass, the point end at P, and then I'm going to open my compass until the pencil is at A. Once I have that measurement set, once I have my compass open from that point P, measuring to A, without changing that distance, you notice again, I am not touching the pencil side at all. I'm going to pick up my compass and place the point at A, and then I'm going to draw a little arc crossing that ray that I just drew. And where it crosses there, that point, that is A prime. A prime is now twice as far away from P as A is. And then we're going to repeat that process with B and C. Then we're going to draw a ray through from P through B. We're going to measure that. And then do the same thing from P through C. And again, once I have that ray drawn, I'm going to use my compass to measure from P to B. And once I have that measure set, I'm going to pick up my compass, move it to point B, and draw an arc crossing that ray we just drew. And where the arc crosses the ray, that point there on the ray is going to become my B prime. And then again, I need to repeat that one more time for C. So I'm going to go from P through C. And once again, use my compass to measure from P to C. And once I have that measurement, I'm going to pick up my compass, move it to point C, draw a little crossing arc, and that's going to become my C prime. Now you're going to use a straight edge to connect A prime, B prime, and C prime to create a new triangle. I know your rulers, your straight edges are a little bit shorter, so from A prime to B prime, you may need to use like the edge of a notebook that's a little bit longer, because that connection is longer than your straight edge, unless you happen to have your own straight edge. So after you have connected, bless you, all three vertices, you should have a new triangle that encompasses your original triangle. And it says to, in a different way, shade triangle A prime, B prime, C prime. Since I went side to side, left to right on my first one, I'm going to go up and down. I'm going to turn my shading the other direction so that they stand out from each other. And again, it's just another light shade. We do not have to, we are not trying to color it in. We are just going for a light shading. So that's what I have after following all the directions for triangle ABC. All right, so again, that's our triangle ABC. Now if we go on to the next page, we're doing something similar with triangle DEF, but this time the point is going to be on the triangle. So again, it does say lightly shade triangle DEF. So I'm going to start off with lightly shading triangle DEF. And then it says draw a ray from D through E. Now, we need to make sure we're drawing this long enough. You're going to need to draw your ray all the way up through the directions at the top of the page to have enough room. So when you set your straight edge here from D, D is acting as our center point now. line up our straight edge with E. And I'm going to make sure I draw that ray again up as high as I can to make sure I have room to do what I need to do. So again, you're starting at D, going through E on drawing this ray. And it should look like this. Now again, they want us to measure. It says use your compass to mark off E prime 3 times as far as E from D. So again, same directions as the previous page. I'm going to use my compass to measure from D to E. So I'm going to put my pointed in at D. And then I'm going to use my compass, open it up to measure to E. Once I have that measurement, I'm going to pick up my compass, put it at E, draw a little arc. But this time they want 3. That's only 2 times away, so I have to pick up my compass again to that arc I just drew and draw a second arc. So where that second one crosses, that becomes E prime up here. Then they want you to repeat those steps from D through F. So do the same thing starting at D, going through F. Again, make sure you're drawing that ray long enough because we have to go 3 times. I'm going to have to move my paper down to be able to fit my straight edge to draw this ray. Because again, I want to draw it out as far as possible because I know I have to go 3 times this time. So I've drawn my ray from D through F. And again, once I have that, then I need to measure from D to F, putting the point of my compass at D. And then opening up until the pencil is at F. That's how I am measuring. Once I have that measure, I pick up my compass and put the point at F. Draw a little arc. But then I need to pick it up again and draw another little arc. So this second one out here, that is now F prime. And then the last step, connect E prime to F prime. And then again, it says in a different way, shade the larger triangle now. And this is what we should have. All right, for a minute, I'm going to switch over to my computer notes here. Oops, I did not change classes. All right, so obviously all the work I just did is not going to show up here on the computer because I can't use a compass on my computer. But I can get to that second page. There's a question that says, look back or think back to your two dilations in the coordinate plane from the activity coordinate dilations and compare them to these two dilations. How does the location of the center point of the dilation affect the location of the image? So the coordinate dilations were the activity we did previously. On both of those, the center point was outside of the figure. Today, our center point was either inside or on the figure. So when the center point is outside of the figure, the pre-image, and remember the pre-image is the original. That's what we start with. We call that a pre-image. The pre-image and image is what we create after the dilation, may or may not intersect. On the first one we did on the coordinate dilations, the two were completely separate triangles. The second one we did, one of the vertices touched the pre-image. Now, when the center point is inside or on the figure, the pre-image is contained within the image. So both of today's dilations, when we completed them, our original was inside of the dilation. It was a part of the image. All right, the next thing they want us to do, if we go to the next page, it says, now you will investigate another special property of dilations. Look at each segment of your first two triangles, triangle ABC and triangle A prime, B prime, C prime, and find the length of each segment in centimeters. And this is important. We need to make sure we are measuring in centimeters to the nearest tenth. Label the length on each segment and list the lengths below also. So I'm going to switch back to my paper and pencil images here. I'm going to go to the first one we did, triangle ABC and triangle A prime, B prime, C prime. And I'm going to measure. So I'm going to take my ruler, making sure I'm measuring in centimeters. So I need to look and make sure, for me, centimeters are going to be along the top. When they talk about tenth of a centimeter, remember they're talking about each of these little lines. A centimeter is broken up into 10 millimeters. So each of those is a tenth. So first I'm going to measure from A to B. I need to make sure I'm starting at 0 with my measurement and then getting to B. So that looks about like 9.7 because the longer one would be 0.5. So it looks like I can label AB as 9.7 centimeters. Now to measure A prime, B prime, we are going to have to move the ruler down because it's going to be longer than the ruler, but you can move that. If I measure C to B, I'm going to start at 3 because my ruler, what's holding up my computer is in the way. So that's 1, 2, 3, 4, 5.5 centimeters. And then if I measure from A to C, that looks like it's 6.5 centimeters. So I'm going to pause for a moment while you measure A prime to B prime, A prime to C prime, and C prime to B prime. I'll give you a couple minutes to get those 3 measures in for me, and then we'll talk about them. Now, as I've said before, anytime that we are responsible for creating something to collect the data, there's always the chance of human error being involved here. If I didn't set my compass exactly and draw those arcs exactly, or if I didn't measure exactly, so there is the room for a little bit of human error where we could be off by 1/10 or 2/10 of a centimeter. If you're off by more than 2/10, that's more than human error. That's just being careless. So there's a difference between human error and not really paying attention to what we're doing. So the measurements I'm going to put on here that I got could be a little bit off from yours. And again, that's human error involved. So for A prime, B prime, I got 19.4 centimeters. And for A prime, C prime, I got 13 centimeters. And for C prime, B prime, I got 11 centimeters. Again, could be off by a little here or there. Measurements really need to be as precise as possible, but we are human. If our hand moved a little when we were drawing or doing something else, our measurements could be off by a little here. So now we need to do the same thing on the second drawing we did for triangle DEF and triangle DE prime F prime. If I can get the papers to move apart here so I can get to the second one. So now we need to go back through again. I'm going to pause for a couple of minutes while you measure. Remember, you're measuring all 3 of the little triangle here, and then you're measuring all 3 of the larger triangles. So I'll give you a moment. I will tell you that from D to F, just to get you started, I got 5.4 centimeters. So I'm going to pause while you get the rest of those measurements real quick. So again, I'm going to put what my measurements are. We should be within 1/10 or 2 of a centimeter of each other. I already wrote that DF was 5.4. For DE, I got 3 centimeters. And for EF, I got 4.8 centimeters. Then for DE prime, this full side here, I got 9.2 centimeters. For E prime, F prime, I got 14.6 centimeters. And for D, F prime, I got 16.2 centimeters. So again, your measurements should be within 1/10 or so of those if we are paying attention to detail. Maybe 2/10 off, but anything greater than that, we're just being a little too careless with our measurements. So now we need to take all that information and fill it in on page 19. So I'm going to switch back over here to my computer notes. All right, so for AB, I got 9.7 centimeters. For A prime, B prime, I got 19.4 centimeters. For BC, I got 5.5 centimeters. And B prime, C prime, 11 centimeters. For AC, I got 6.5 centimeters. And for A prime, C prime, 13 centimeters. And then before we talk about it, I'm going to write in the other one as well. For DE, I got 3 centimeters. For DE prime, I got 9.2 centimeters. For EF, I had 4.8 centimeters. For E prime, F prime, 14.6 centimeters. DF, 5.4 centimeters. And for DF prime, 16.2 centimeters. So now what we need to look at is what were the scale factors? The scale factor of my first one of triangle ABC, we had a scale factor of 2. And I should be able to see that if I take the number over here times 2, I should end up with my measurement over here. And I believe 9.7 times 2 does give us 19.4. 5.5 times 2 gives us 11 centimeters. 6.5 times 2 gives us 13 centimeters. And then our second drawing had a scale factor of 3. And you'll notice if I start with my original triangle and I multiply it times 3. Now on this first one, I know 3 times 3 is 9, but I got 9.2. Is that within an acceptable length? Yes. Again, I probably was a little careless in getting my line straight, but 9.2 is awfully close to that multiplying times 3. 4.8 is what I got. And if I multiply this times 3, I got 14.6 times 3 would be 14.4. Again, I'm within acceptable. I obviously was a little more careless on this triangle. My human error kicked in a little bit more. And then if I take 5.4 times 3, I do get 16.2. So a little bit of carelessness there. Not bad though. I'm within the acceptable range there. But it shows in our measurements how our new one is, in the bottom case, 3 times bigger than the original, or in the first time, 2 times bigger than the original. We're showing that in the measurements that scale factor actually did happen. So it says, what important property of dilations can you identify from your example? A scale factor is used as a multiplier to change the side lengths of the pre-image or of the original. So that scale factor really is a multiplier. We can see it in the 2 we did today, where we can multiply by the scale factor and come out with the lengths of the image that we created through dilation. Then they want us to rewrite the formal definition of dilation. We wrote it yesterday. So dilation, a transformation that moves each point along the ray through the point emanating from a fixed center and multiple distances from the center by a common scale factor. All right, then it asks us to recall and write the other important property about image lines of a dilation. So today we explored the important property of the scale factor really being a multiplier for the lengths of the sides of the image versus the pre-image. Yesterday, what important property did we uncover? What was the coordinate, the main idea of the coordinate dilation activity? What were we measuring in the coordinate dilation activity? The slope. So the slope of the lines remain constant under dilations. So within the last two activities, you have shown that the image and the pre-image, those lines stay parallel. We are changing the size but not changing the shape. And you have proved that the scale factor really is a multiplier that is used to create that image from the pre-image.